Hey everyone, thanks for joining our live Kubernetes workshop. I'm Arsh and I'm a developer experience engineer at Octeto. If you've been following our content, you know that we have produced a lot of things related to Kubernetes. We have our hands on Kubernetes guide where we cover a lot of the Kubernetes resources in detail. And we have been periodically creating content about different Kubernetes concepts because we understand how complex Kubernetes is and how, you could just take one particular resource in Kubernetes and just spend days studying about it. And after that, there'll be stuff you still don't know. So, with that, we came up with this idea for webinar as a sort of hands on exercise because we have done a lot of written content before. But I personally feel that the best way to learn a new technology, especially something as complex as Kubernetes, trying things out yourself. And that's why we came up with this idea of workshop containerized app and try to deploy it on Kubernetes. And this isn't going to be, something like I'm writing Kubernetes YAMLs for my brain because nobody does that. So we wanted it to be like a hands-on real like I'll use things I do when I'm trying to deploy an app on Kubernetes. And earlier that used to be like the Kubernetes. Now I'm finding ChatGPT to be much see how you actually take an app and just deploy it. We've got quite some task ahead of us. So, any spending any more actions, let's just get started. I'll pull up my screen and give you a brief about the application we are working with. If you have seen some of our latest videos on our YouTube channel, which you should subscribe to if you haven't already, we have been working with a to do list application which allows you to input to dos and edit them and delete them. Now, I have this application cloned on my local machine. And if you want to follow along with this workshop, or maybe later if you're seeing, make sure to check out the Docker Compose Octeto branch because that'll be our starting point. So, this application right now has three microservices. We have a React client, which is for our application. We have a Node.js Express backend server, which is responsible for communicating with the front end and the database. And of course, we have a Postgres database where we store all our to dos and the backend server interacts with that. Now, we have a Docker Compose file for this. Let's just take a look at that so we understand how this application is structured a bit more. And then we, start to take these containerized microservices and actually get them to run on Kubernetes. So if you see, we have three of our services defined in this Docker Compose file. The front end, we built it from the Docker file, which is there in the client for building the front end. Similarly, we have a Docker file for the backend as well. For the database, you'll see that we do not build any image. Instead, we use the Postgres image. And we have a volume, and we'll get into this when we cover Kubernetes concepts. What's the point of this? And that's it. So, three services exposed on different ports. Two of them have a file, and one we are just using the Postgres image. So, let's get our hands dirty with some Kubernetes resources and try to migrate this app. Um, Before we continue, I would just like to say that I'll be checking the periodically. So if you have any questions, please feel free to type them out there. I'll also try to answer your questions as soon as they come. But in order to just maintain the flow, I'll probably check them all and then get to each of them. And obviously, we'll have a Q&A at the end. So there we can answer any questions you might have. Awesome. So let me tell you about what cluster I'm using. I'm using a CVO cluster, which is my favorite clusters to use for workshops and webinars or just experiments simply because how fast it spin ups. It's a lightweight cluster. By the way, CVO reminds me that we are going to be at CVO next week. So if anyone is attending, make sure to at a booth, come say hi, chat with us, and collect some awesome swags. So this cluster I'm working with has three nodes, and those of you who don't know, I have an alias set. So K is basically short for kubectl. But this is a three-node cluster which we'll be working with. And let's start by first creating a folder called manifests where we'll just be putting all the Kubernetes manifests we write today. Now I want to migrate this app from like the most independent service to building on top. Okay, so for example, the I feel like the front end is the most dependent service and hence the least independent service. It requires the backend, it requires the database. So if you start with that, it's just going to be tough migrating this app to Kubernetes because we'll hit roadblocks where we would need things from the back. So that's why I prefer starting at the bottom of the ladder, which would be the database, because the database can, in isolation, run on its own. So let's file called db deployment.yaml, and this is where our deployment for the database will be. We won't be covering in detail what a deployment, basic Kubernetes concepts we have discussed in detail thoroughly in our blog, which you'll find on our website, octeto.com/blog. So are not familiar with these concepts, I would encourage you to go to our blog and read the Kubernetes basics guide and then come back to this webinar or the recording, because you'll be able to absorb the content much. Now, before we get to this deployment.yaml, and don't worry, we are not writing this from our hand. We'll ask ChatGPT to help us out. But let us look at this database service. You'll see that this database service has an init.sql. And what this file basically does is it has some initialization instructions for the database. Is just creating the database, which is called to-do list, and the other is creating a table inside that particular database. So we want to run this script as part of our deployment, as part of like when our database pods get created, because if that table does not exist, then our application won't database or like create to-dos in that table. So let's go back to ChatGPT and ask for a Kubernetes YAML. If you see the prompt I gave it, I asked that give me a deployment which uses an init.sql from a config map. Now, map in Kubernetes is a resource which stores like information, I would say. And what we'll do is use this deployment to, map and get all the initialization instructions. I'm not sure why this is stuck. Okay, yeah. ChatGPT is getting slow. See what it gives us. So we see a config map, and that's exactly what we need. And while it does that, let's create a new file for db config map.yaml. And this is where we'll store our config map. And let's copy the file we got from here. And you see, this is nothing special. It's just a config map resource which has a name. And then there is a data key with the init.sql key and the initialization instructions. Now we'll replace these instructions with the ones we want for our application. So I'll just copy and paste, fix the indentation, and that's it. So our config map is now ready. Now we want a way to use this config map in the deployment, and let me show you what we do by first just copy pasting this deployment resource, and then we'll go line by line into what it does and see. All right, so let's see. It's a deployment resource. We have its name and its deployment. Let's just call it database. Um, then for this, we'll just have one replica, which means this deployment pod, which would run Postgres for us. And the labels also, I would like to change them to database because it's just matching with all of our folder structure. The container names, we want to use Postgres, that's fine because that's how I know that I'm running a Postgres container. The image is the Postgres latest image, which it will get from Docker Hub, which is what we in this case. The container port is the port like Postgres listens on, and this is the default port. And then we want environment variables. These are the environment variables our app will be using to connect to this database. And if we go to the server, we'll see that in our application we have a db.js file, and in the we use the values to connect to the database. So we want these values configured for as environment variables as well. In case this is getting confusing, whatever values we specify here are the values which will be used to authenticate with the Postgres database. And since we know that our application expects these values to be values, we'll replace these values in this application is actually going to use. So let's see. The first is the database name, which is to-do list. So I'll add that. Then it will try to log in with Postgres user. So I'll add that. And the password, it'll expect it to be Postgres. So we want that to be true. Then this is part. You see that in the volumes mount section, we have a volume defined called init scripts, and this is reading from our config map, our Postgres config map. So if you see here that it's reading from that Postgres config map, and it's mounting what it reads at this particular folder. Now, if you go to the Postgres Docker Hub image, and let's just search for this structure and read more about this. I want to show you like how I would go about this and like when I'm actually doing stuff. That's why we are referring to the documentation and you know not writing those YAMLs by hand. Nobody does that in real life. So you'll see that initially to do any additional initialization in an image from the official image, add one or more under this particular folder, and that's what we are doing. So we what this will do is that it will create a file called init.sql and put it in this particular mount path, and that's why we are leveraging, like that's what benefit we get from leveraging a config map. Awesome. Now that we have both these manifests done, let's just apply them and actually verify what I'm saying is correct or not. Do we actually see an init.sql and a database? I'm just going to apply these manifests. Until then, I'll go to my terminal and spin up K9s. K9s, by the way, those who don't know, is an amazing tool to work with Kubernetes clusters. It makes things super easy. So I would highly recommend you install this. And if you don't know how to use it, it's pretty simple. I'll show you how in the context of this like video. But it's not an absolute requirement. You can do all of the things I'm going to do by just running kubectl commands as well. But it's just prettier and easier. So that's why I go with that. So we see we have our config map and deployment created. Now, if you go to K9s and if you press colon and then type namespaces, or you use the short ns, you'll see that we have like all the namespaces lifted. Now, if we go to the default namespace, we'll see our database pod is up and running. If we press enter, we'll see the containers part of this pod. And I think you can see here that we see that if I press S, I would get a shell inside this pod. Now, this is the same as running kubectl exec -it and -- bash or whatever command you want to run. But here I just have to press S. So let's do that and I'll get inside this pod. Now I'll do ls to see the folder structure, and I see that this folder exists, which we referenced in our Kubernetes manifests. So let me go in this folder, ls again. I see that my init.sql file is there. Now that's a good sign. That means our config map was mounted inside this Postgres pod. Let's see the contents of this file to verify if they are what we expect, and sure they are. But that's not enough. Like I want to verify if my table created table called to do and if my to-do list database has been created. So let me just log into Postgres and verify these things. So I'll do this now. I'm inside Postgres and I think \d should give me a list of, no, I think it's \l gives me a list of all the databases. So I can see that my to-do list database exists. That's good. And I can connect to this by running \c to-do list. And now I'm connected because we want to be sure that our to-do table, a table called to-do exists inside it. So \tt is the command to see all the tables. I run it and it's there. That's a good sign. So we know that everything on our database side is working. And coming back to our building our ladder, like climbing our ladder from the bottom up, this means one component is ready. So let's start to move on to the next component, which is the backend service. I'm gonna exit out of this by running it again, and I'm back here. Cool. Pressing escape takes you to the previous menu in K9. So now let's go back to our VS Code and create. Before that, actually, our backend is going to be talking to this database, right? And in Kubernetes, if you have read our guide, you know that pods don't talk to pods directly. I mean, they do in certain cases, but not in the cases of like different microservices. So what we want to do is to expose all the database pods. Right now, we only have one pod as part of our deployment. But if you're doing this in production, you would have like three. I don't know. You could have any number of pods you want, and you want a way to direct traffic to all of those pods, like all any one of the available pods, not one particular pod. And that is why you create a service to expose the pods which are being managed by a deployment. So let's create this service. And if I remember correctly, I saw in the chat GPT output, we had a resource for the service. I'm going to copy this and add it here. The name is fine. Interesting part. The name needs to be what is being referenced in your db.js. So the host, the application will try database host, and that is what the name of the service needs to be. That's what we'll do here. And the spec, we know that the way the service will identify the database pods are by using the label we provide here. And our database pods have the label called app database. So that's the label we want to use here as well instead of app Postgres. So I'll copy paste this, hit save. Now we have a database service. No need to apply it right now. Let's create our backend service as well, and then we can apply them together. I'll create a file for server deployment. And this is going to be another instance where we'll rely on ChatGPT for help. So give me Kubernetes deployment for a Node.js Express backend server. I don't need that many keywords, but it's fine. See, it's saying that you can adjust the replicas. Okay, whatever. So it provided us with a service also, which we don't need this time because services kind of look same for services. Um, yeah, let's just copy this deployment which we got and go through it line by line, understanding. So same story. It's a object of the kind deployment. The name, we are going to change it to server because we want to ensure consistency with our folder name. This is not a hard, it's just something I'm doing. You can call it whatever you want. Replicas, let's just change it to one for convenience, and you change it to whatever you want to do in production. Again, match label, I would prefer if they are just called the same thing instead of backend. Template is where you start to define the like how the pods look like for this deployment. So you see that these are the labels for the pod, spec, container name, backend, sure, why not. For the image, I have already built these application like for each of these like services and push them to my Docker Hub. So we can just use those images. And this one is called slash octeto to do server. Not the most pronounceable name, but anyways, just copy paste this image, or what you can do is just clone this repository Docker images for each of these services and push them to yours. But it's totally fine if you use my images. The container port now, reference to our Docker Compose YAML, we'll see that the backend is on the port 5050 instead. So I'm just going to copy that and add that. And that's it. This is a fairly simple deployment.yaml. What we also need is a service to expose the server pods, just like we did for the database pods. So I'm going to go here and create a server service YAML. And we can actually just copy this database service and modify it a bit, and we should have our server service. So we'll change this to server, and the ports we know are 5050, not 5432. And that's about it. It was like fairly simple. Now let us apply these manifests and see if our service is being able to talk to the database. Okay, we have all these resources created for us. Let us head back to K9s, and we can see that our server is currently in the container creating state. So let's wait for that to happen. Awesome. The server pod is now running. What I want to do is actually verify that this pod is being able to talk to the database. Now, currently, the database does not have any to do stored in it. But if the server, like if we try to get the list of to dos, we should still get back an empty array, right? Instead of edge. So I want to ping the server service. Um, yep. Okay. Hi, Pritish. Hi, William. Is the connection lost? I think there was some problem on my end, but I'm back now, right? Can someone give me a thumbs up? Okay. Um, cool. Awesome. Thank you for verifying. We can take the screen off right now while I read chat. Awesome. We have a poll, by the way, so just fill out the poll and we'll get started in another 30 seconds. Awesome. No questions so far. So this was fairly simple. Now the next 5-10 minutes might get a little complicated. So let's action. I'll bring back my screen now and we'll start to work on the final microservice, which is the client microservice. Again, Similarly, just like we did for the server, let's create a deployment for the client as well. And this will be fairly similar to the server deployment. So we are just going to copy the server deployment. And actually, I have too many of these open. So let me just close some of these down and just add it here. And I think for this one, we can just replace all the instances of server with client because everything is fairly simple. And the way I'm selecting multi is, by the way, with Command D, which is one of my favorite features about VS Code. I can change all of these at once, hit save, and now I think I should change this as well, last piece. But yeah, now our client deployment is ready and the port needs to be changed. Let's see what the port number is. It's 3000. I'm a Docker Compose file because it's easy, but you can see all of these ports in the Docker file also for the respective services. You see, it's exposing port 3000, so we know that's the port we want to use and deployment as well. So the deployment is now ready. What we need to do is create a service as well for this. So I'll create a client service.yaml. This is going to be similar to the server service. Let's copy this from here. Change this to client and change the port to 3000. Oops. Awesome. Now let's go back and apply all of these manifests and just see if our application is in a healthy state. So we say that we have created the client service and we are seeing that the client pod is in the container creating state. But this is where things start to get a bit tricky, right? We were able to verify that the uh, backend pods were the database because that was like they were like on the same port, right? Like it's all the networking is happening inside the Kubernetes cluster. But now we want to expose this application and we cannot just, do a port forward and expose this application. The way you expose applications on Kubernetes is with the help of an ingress resource. So what an that right now all of these services are like their individual things, right? They're running on different ports, but when an application is up and running, everything is behind the same DNS. And you might have like hello world is, let's say, your application. Then you hello world.com/API, which the front end makes requests to, and that's how the application interacts. So we want to do all of that configuration, and that is an ingress Kubernetes resource. Now, ingress is like one of the tricky Kubernetes resources. I'll try to simplify it as much as I can for you. But before we get to the ingress, the fun part is that just creating an ingress does not work because we need an ingress domain name where it'll route your different services to, like, traffic to different services based on what endpoint you're hitting. And so before we can create the ingress, we need a domain for our application. Now, where do we expose this like application? For that, on Kubernetes cloud, you would need to install an ingress resource like an nginx ingress or something like that, an ingress class basically. So the most popular ingress classes out there are nginx ingress, traffic, and there are other solutions as well, but these are the commonly used ones. So depending on your cluster, now you have different paths to take here. If you are on a GKE or AWS cluster, you would have to install the nginx ingress, or ingress nginx. I don't know which one the official one is. But yeah, it's Nginx ingress controller, and you would need to install this on your Kubernetes cluster. You can follow the install. But for me, since I'm using a Civo cluster, Civo already installs an ingress controller for you, and they install a traffic controller. And you switch to namespaces, and I go to the kube system namespace. You'll see that I can see all the traffic pods running. But what this does not is give you a service of the kind load balancer. Now, all the services we created right now were of the type cluster IP. Cluster IP services are perfect if you want your application services to talk to each other inside the cluster. But cluster IP services won't allow anyone from an external traffic, like you as a user, to interact with my application. For the load balancer type service. So that's what we are going to create. And let's see the documentation for the traffic and see what they have for creating that. As we do these steps, they'll start to make more sense. So you might want to, rewatch the recording after you've seen it in action to put the pieces together. But on the quick start guide, I see a Kubernetes section. So let's go to that. We see permissions and accesses, and luckily we don't have to do any of that because Sivo installed traffic for us. So we have all these service accounts and the traffic deployment as well. And that is why we are able to, see these traffic pods. So that all has for us. But what has not been configured is this service of kind load balancer. So let's create this. And I'll just this from what they have. This is the dashboard service. We don't need the traffic dashboard. What we need is the web service. So I'm copying this and creating a new manifest called traffic service.yaml. And I'll just copy paste this. And the namespace, we'll add the namespace key here because we want it to be in the same namespace as the traffic pod, which is the kube system namespace. The type is of load balancer we want, and we can leave the default settings. Selector again is the part where I told we need the labels which are there on the traffic pods. So let's check these pods and see what labels they have. And K9 tells that I can press D to describe and see the pod. So I do that and I see all these labels. Now the unique one you can see is managed by Helm. So this label would be there on all the applications which Helm is managing, I'm assuming. But this one seems unique, right? Um, so I'm going to copy this and go back to VS Code and put this label under selector. And I think this should work, but with Kubernetes. So let's apply this and see if we get a load balancer type service. And we can go to services here. And we see that before this load balancer type service, there was only cluster IP services. So there was no way to access anything deploy publicly. But now our load balancer service see an external IP here. So let's copy this external IP and check it out and see what we get. Ideally, it should be like nothing or maybe the default traffic page. If you're using Ingress and Nginx, then that would be a different story. But yeah, see 404 page found. That's a good sign because we know that at least that endpoint is working. Because if you just type some random numbers, you will get an error. Now what we need to do is DNS, configure a domain into this endpoint. Now, I'll be using Google DNS, but you can use any DNS service you prefer, or you have. So I'll add a record set and I'll call this to-do list and I'll point it to the IP address we got for our load balancer service. And just wait for this DNS entry to get created. I think it's done getting created. So we can just go to this URL and we should see 404 page not found when we hit this. And we see 404 page not found. That's a good sign. Usually it's in this case it is. Now what we can do is, since we have a domain configured application, we can create an ingress resource. So let's create an ingress.yaml and again leverage AI superpowers by ChatGPT and say, give me a ingress YAML for uh, React and Node.js service application. Ingress Kubernetes YAML maybe. Yeah, whatever. We just need some basic structure and we modify it. Looks good. Copy paste this to VS Code. Let's change some names. App Ingress, sure, why not? Host is the actual DNS. Oops, I forgot I'd copied the entire YAML. I'm gonna go back and copy this. So we'll replace this with our DNS name, which is todolist.octeto.me. Now this is where you can routing for your application. So if someone just hits this to-do list octeto.me URL, which is like the default path, we want them to be directed to the front end, right? And the front end is being exposed by the client service. So we'll just write the name for the client service, and the number will be the port that service was like listening on or on, which was 3000. Let's just double check. Yep, client is on port 3000. And when someone hits like the backend, and let's see what our backend, we can see that our backend URL for our application is like, see all the components are making requests to forward slash to dos. So URL for our backend. So we'll replace this API with to dos. And whenever the application will try to make a request to forward slash to dos, we want to read that request to the backend pods, which are being served by the server service, which will serve them to the server pods. So let's change the name of the service to server. And if we go back, we'll see that the server service is on port 5050. So we go back and change this to 5050, and that should be it. If we have not forgotten about anything, this should give us a working application. So let's apply all of and see. So we see most of the things are unchanged, but our ingress is now created. So let's go back to our application endpoint and see if we get something. I'm going to hit refresh, and voila, we see our application is now up and running. But this is just the front end. We still don't know if it's being able to make requests to backend or not. So I'll add a to do, and fingers crossed it worked. Let's just check other parts. Edit is working and delete is working. So this is it. We deployed our application to Kubernetes in about 30 minutes or 40 minutes, I would say. So pat yourselves on the back if for this was like complicated and tough to wrap your head around it the first time. Like, it takes time and practice to understand these concepts, and it always has to be a mix of reading about these concepts from the documentation, different blogs, and trying them out on your own, because that's how you will like get experience with Kubernetes. And if you feel intimidated by Kubernetes, it is, just know that it happens with everyone. It's not an easy piece of technology. So just keep trying. And I'm going to stop sharing my screen and now just see all the chat as well. But to sum up what I was saying, that Kubernetes requires practice migrating your applications to Kubernetes. And that's why like there are a lot of these CNCF projects and different tools which help you with the migration. And just know that you have to take it step by step and migrate applications to Kubernetes. But it is almost like worth the effort you put in, because we all know that before Kubernetes, scaling applications was like just insanely tough, right? And that is why we containerization and microservices. And Kubernetes allows us to run these containerized microservices at scale and make sure that there is very less downtime for our applications. But what happens with Kubernetes is that when people think of migrating to Kubernetes, they think of the production side, and everyone invests resources in migrating the app to the production. But what I want to encourage you to start thinking about how development will look like when you migrate to Kubernetes. Now, because once your application moves to Kubernetes and you have all these like deployments and config maps you saw, you cannot have your developers using like the same old development techniques. They can running like containers locally using Docker Compose, or not even that, just running these services locally, because this would create a huge mismatch between your production and development Kubernetes configuration. So just some food for thought to think about these things as you go along in your Kubernetes migration journey. If you are already thinking about these things and realize the importance of development experience, I encourage you to check out Octeto and the platform we are building. We help people develop on Kubernetes, and we help take away all the complexities you saw we did in this. Like, if you were to replicate this production thing we did for migrating for each developer because they want to get developing in a similar configuration, you can see how easily each developer would be spending like 45 minutes, the duration of this webinar, just trying to create these services. Even if you have them created for them, just creating those like endpoints, ingress endpoints, and all of those things, it's just a frustrating experience as a developer having to do that as part of your day job. So this is something platform engineers and DevOps engineers need to take care of, and that's where Octeto fits in. Octeto allows platform engineers to automate all of these like complexities we navigated for developers, and it allows you to just provide an environment for your developers in one single click and get them developing. For tuning on, we have survey for you to fill out if you like this webinar. So it would help us a lot, and it would help us create content for you in the future. You could tell us what kind of things you preferred, if you found this useful, where you are in your Kubernetes adoption journey, and all those kind of things. So this webinar, please just fill out the survey and let us know your thoughts. Other than that, if you want to learn more about Octeto, it can help you, solve problems for your development when you migrate to Kubernetes. Go to our website, click the Try Octeto button you see on your screen, sign up for our free 30-day trial, and you'll see that how, like you'll abstract away all of this complicated stuff we did in this webinar for your developers and be able to provide them with an amazing development experience. Thank you for tuning in. I'll stay on for like a couple of seconds and see if people have any questions related to the webinar. And if you have, please post them on the public channel. I'm here. By the way, this application is live, so if anyone wants to go to do this.octeto.me and play with the application, please feel free to do so. It'll be live for like 15 minutes, and I'm going to delete everything after that. Awesome. It looks like there are not many questions. So thanks for joining, everyone. We'll be sending resources, the application I used, in a follow-up email. So make sure you keep an eye out for our email, and if you like more of this content, more of this Kubernetes based content, subscribe to our newsletter, check out our YouTube channel, and check out our blog. We post a lot of these related content there, and it can really help you if you're trying to learn Kubernetes. And thanks for tuning in.